What minimum diameter of pipe is necessary to carry 0.5 pounds per second of air with a maximum velocity of 18.5 feet per second? The air is at 80 degrees Fahrenheit and an absolute pressure of 34 psi. So this is another gas flow problem. We're dealing with a compressible fluid. Our fluid is air, and we're going to treat it as an ideal gas. What we'll need to do is we'll need to calculate the molar and mass density of the air, and then we can solve the mass flow rate equation for the cross-sectional diameter. And remember that mass flow rate equation is the mass flow rate is equal to the density, this is a mass density, times the linear velocity times the cross-sectional area. So once we know that we're given the mass density, right? We'll be able to calculate, we're given the pressure and the temperature, so we'll be able to calculate the density of the air. We're given the linear velocity, right, at 18.5 feet per second. And so what we're going to need to do is calculate the cross-sectional area, and then from that get the diameter of that pipe that will be used to carry this air. So let's write down all of our given information first. Mass flow rate, the velocity, temperature. Remember, we need to work with temperature in absolute temperature when we're dealing with ideal gases. I've got the molecular weight of air, 28.96 grams per mole, our ideal gas constant, and our pressure is 34 psi. And notice they were nice to us here. They did not give it in gauge pressure, they gave it in absolute pressure, so we can work with that pressure directly. So our mass flow rate equation is just, like I said here, the mass flow rate is equal to the density on a mass basis times the linear velocity times the cross-sectional area. And so we are given the mass flow rate. We'll be able to calculate the density. We're given the linear velocity. And what we will do is we will solve this equation for the diameter. And so using the ideal gas law, we will calculate the molar density and then convert that to mass density. So the molar density is N over V, and that's equal to P over RT. And so we are able to calculate a molar density of 94 moles per meter cubed. We multiply that by the molecular weight to convert that to a mass density of 2.72 kilograms per meter cubed. And so now we can take our mass flow rate equation above and we can solve for the diameter. And so we simply take this, do the algebra, solve for the diameter. And so MathCAD, I use MathCAD Solver to do this. It's a little awkward, but it gives you the same equivalent answer. We solve for the diameter. It is 13.7 centimeters, or about 5.4 inches. So a pipe of 5.4 inches is the minimum diameter that we'll need to carry air at this velocity, these conditions, for a mass flow rate of 0.5 pounds per second.